Madam, live, please start.
Hello. Yes. Okay. So we'll start. We'll start this webinar. Namaste. Good evening.
Good evening.
All the teachers, students, Vidyadan Foundation, Honorable Padmashri Pramod Kale sir, I welcome one and all to this webinar. This is in the memory of Dr. Vikram Sarabhai. Today being his birth anniversary, we are organizing this webinar. On behalf of Vidyadan Foundation, I welcome you all to this session. It's going to be interactive session with Padmashri Pramod Kale sir. Vidyadan Foundation is committed to education at grassroots level in Kasaragod, Kerala, and many other places. And today, the students have gathered here from far and wide to witness this webinar, this virtual meet. And it's going to be an interactive session with Padmashri, Dr. Pramod Kale sir, former director of ISRO SSC Satellite Application Center, Ahmedabad. In the memory of Dr. Sarabhai, we thought this is the apt moment to discuss the leadership qualities, scientific leadership qualities that he possessed. And Dr. Pramod Kale sir, he worked with Dr. Sarabhai, so he has had a great influence and he had a great experience working with him. So therefore, at the outset, we are honored and privileged to have Padmashri Pramod Kale sir today with us. I'll give his introduction. It is very illustrious but brief introduction. Pramod Kale sir, he has served with Indian Space Research Organization, ISRO, for a long tenure, spanning over 32 years. And during this period, he has held distinguished positions, and especially at the helm and leadership positions at ISRO Ahmedabad. Pramod Kale sir is India's renowned space scientist who was handpicked by Dr. Sarabhai, the father of Indian space program, back in the 1960s. And he has held many remarkable designations at ISRO. Pramod Kale sir was born and brought up in Pune, and he completed his matriculation in Pune and then went to Vadodara for his studies. And he did his BSc Physics at the University of Baroda, and then MSc Physics and Electronics from the Gujarat University, Ahmedabad. Initially, in order to gain practical experience in electronics, telecommunication, and space research, Kale sir worked at India's ACE Physics Research Laboratory, PRL, Ahmedabad, and while simultaneously pursuing his MSc. Then during that period, he also got to conduct work on developing satellite tracking, etc. He got selected to work with Dr. Vikram Sarabhai for research in the PRL team itself. And he was then seen to be a very enthusiastic physicist and engineer. So Dr. Sarabhai clearly saw this enthusiasm and spark in him, and towards space technology and engineering. Therefore, Kale sir was, when he was still a student and he was pursuing MSc, he was then selected in 1963 to be a team member for the construction and establishment of ISRO's TERLS, Thumba Equatorial Research Rocket Launching Station at Thiruvananthapuram, Kerala. Then later on, he was deputed to work at NASA's Goddard Flight Center in the US. While working at ISRO, he was also invited to a short and brief stint at NASA. So with his immense knowledge and expertise in satellites, telecommunication, microwaves, engineering, antennas, etc., especially when it comes to many of the initial projects, INSAT and IRS, etc., and even ranging to even today from Chandrayaan 1 to 3, the present Chandrayaan 3 mission. He has had connection in all these projects. So during his illustrious career, Kale sir has been conferred with many awards, accolades, and recognition. Some include Sri Hari Om Ashram Prerit Vikram Sarabhai Award in 1965, Padmashri in 1984, Ramlal Wadhwa Award from the IETE, and Aryabhatta Award from the Astronautical Society of India for his lifetime contribution in astronautics, space engineering, and technology. Dr. Kale sir has been instrumental in setting up ISRO cell at the University of Pune, that is now SPPU. Kale sir, with his also association with Exploratory Science Center in BBB Pune, he has been instrumental in also setting up the lab and facility there. And he also enjoys to be with youngsters and impart knowledge and share his knowledge and expertise with youngsters and kids. Today, therefore, sir, we have many children, students who are excited to join here in this webinar and to listen to you about your experience and your association with Dr. Sarabhai and also India's space program, the present and future. So with this, I hand over the mic to you. And sir, you can initially share your experience and then the students will start asking questions.
Okay. I had just completed my BSc in 1960, and I was thinking about research work at that time itself. So the professor N.S. Pandya in MS University suggested that I should contact Dr. Vikram Sarabhai about my ideas regarding research work, particularly since I was interested in space related work. So I went and wrote a letter to Dr. Sarabhai. I got an answer to go and meet him in Ahmedabad. So I went to Ahmedabad and met him. Initially, I was thinking that maybe I will get 5 to 10 minutes with him. But once we started talking, he started asking so many questions. He spent almost an hour or so in inquiring what my ideas were and what I wanted to do in the future. So as a very young student at the age of 19, I got the opportunity to meet him, and he suggested that instead of starting the research work immediately, I should complete my master's in Gujarat University and simultaneously work at the physical research laboratory to gain the practical experience. Because physical research laboratory in Ahmedabad is located very close to the university, right within the walking distance. And I immediately started that kind of work in 1960 itself. And since I knew about the radios and how we could use the radios, one of the first tasks was to set up a satellite tracking radio receiver so that we could get the signals from the Explorer satellite of USA, and which we were successfully able to do. And that led to the establishment of the microlock station by NASA. Now you should imagine that in 1960, around that particular time period, NASA also did not have a full network around the world. So if a satellite is being seen, a low Earth orbit satellite is being seen in USA, they could receive the signals. But over the Indian Ocean area, there was no other station available. So the microlock station was established in Ahmedabad, and that led to the next level, and that is the formation of the Indian National Committee for Space Research, INCOSPAR. Now, this committee was given the responsibility to guide the space research work. Dr. Sarabhai was the chairman of that committee, and our director at the time, Dr. K.R. Ramanathan, he was also a member of that committee. There were many other prominent members of INCOSPAR. And one of the first things that was decided was that we should set up a rocket launching station near the geomagnetic equator. Now we have the geographical equator, but the geomagnetic equator, the magnetic equator passes about maybe 70 kilometers to 80 kilometers north of Thiruvananthapuram. So we selected the site in that particular area, just slightly north of Thiruvananthapuram. And a first team was selected. Four of us were there. Myself, Mr. Prakash Rao, Mr. Ramakrishna Rao, and Mr. Arava Mudan. And we were sent to USA in the first week of January in 1963 to learn about assembly of the electronics as well as tracking the rockets, various kinds of work which would be required to be carried out. And then came the second team that had Mr. AGS Murthy, Mr. Ishwar Das, Dr. M.S. Rao, he was a meteorologist, and APJ Abdul Kalam. He also joined with us at that particular time. And he was the only aeronautical engineer amongst all of our group at that time. And we started working together regarding setting up of this Thumba Equatorial Rocket Launching Station. And then we started the work, understanding everything. And in November 1963, 21st November 1963, our first rocket, Nike Apache rocket, was launched. Now this rocket had a payload. The payload was from France. Professor Blamont was the project scientist from France, and Dr. P.D. Bhavsar, he was the project scientist from our physical research laboratory. The plan was to launch this rocket up in the atmosphere, and then once it crosses about 85 to 90 kilometers height, it would start releasing sodium vapor into the atmosphere at that height. Once that vapor is released in the atmosphere there, it will start glowing in the sunlight. But at the same time, since there was darkness on the ground, we could photograph this cloud from 3 or 4 different locations. And from this series of photographs, then we can find out how the cloud moves. And therefore, we could find out what were the wind velocities. So this was a very, very major experiment we carried out near the geomagnetic equator, and it was quite successful. And later on, it was decided that we should go ahead and establish the Space Science and Technology Center in Thiruvananthapuram itself. And then I moved from Ahmedabad to Thiruvananthapuram. And this our interaction continued. Dr. Sarabhai was in Ahmedabad, and he used to visit Thiruvananthapuram very often. One of the very important things that Dr. Sarabhai was famous for and very well known for was that he would share his ideas with all the youngsters working there. He would tell us as to not just only what we are doing now, but what we should be doing after so many years. And we had decided that we are going ahead with the development of our own rockets, making them, and finally launching a satellite from India itself. And that is how the project SLV-3 was established, which was led later on by APJ Abdul Kalam. And in order to be able to launch this satellite from India, we looked at the Thumba Equatorial Rocket Launching Station itself. But then that was located on the west coast. And now to launch a satellite, we needed a place in the east. And so I started the search for that particular location, traveled on foot, by jeep, by boat also, all the way from Chidambaram and going beyond Chennai up to the Chilka Lake. In between, we came to know that Chilka Lake we should not consider because defense was already considering that for their missiles. So we stopped near the Sriharikota Island, and the island itself was sufficient for our work. And then we acquired that island. So my very good interaction which happened with Dr. Sarabhai at that time was that after I submitted my report saying that okay, this is the place from where we should be launching our satellites, he wanted to see the place. And when he wanted to see the place, at that time, our jeeps or vehicles could not have gone to this Sriharikota Island. So a plane, a small Dakota plane was hired, and Dr. Sarabhai was there. There was this minister from Tamil Nadu, I think Narendran. He was there, the district collector from that Nellore district. And then we got into the plane. And once we were up, Dr. Sarabhai went and sat in the co-pilot's chair. The pilot was there, and I was standing between the two. And I was describing everything, whatever I had seen on the ground to Dr. Sarabhai. And then he would say, okay, let us take it down there. So we'll go down to as close to the ground as possible. And we continued with that. Finally, that place was selected. And that is the time when finishing that work, Dr. Sarabhai said that, okay, now the time has come for you to move away from here and start looking at two things. One was a major experiment which we were planning, that was the satellite instructional television experiment site, in which we were going to use an American satellite for taking the television signals to all of our villages. And the second thing was to start working on making our own satellite, the Indian national satellite, the studies for that thing. And that's how we started the studies in 1968, 1969. And then I was sent again back to the Goddard Space Flight Center in USA. And again, Dr. Sarabhai used to take very good interest in all the things that we were doing. He used to guide us also as to what we should be looking at in the future, how we should be looking at various things, various technologies, and take it up further. But he was very much interested right from the very beginning as to how we could use television for bringing the education, the instruction to our village schools, our agricultural people, everybody. And that is how we conceived the INSAT satellite project. But unfortunately, Dr. Sarabhai passed away in 1971 December. What I would like to suggest now is let the students ask me the questions. Okay.
Yes. Oh, sure. Yes, sir. I was about to suggest that. So there is Miss Gopika. She would like to ask you a question, sir.
Okay.
Good evening, sir.
Good evening.
Good evening, sir. I'm really happy to attend this program because 4 years ago there was an exhibition organized by ISRO in Palakkad, the Navodaya school, and over there it was about Dr. Vikram Sarabhai, sir. And it was really fascinating. The exhibition was really fascinating. And from that time, this thing has been going on my mind that I wanted to know more about space. And I wanted to get to know the people who worked with Dr. Sarabhai.
Okay.
So here is my question for you, sir.
Sure.
So we all know that first encounter with a person has a really special place in our hearts. So it might be the same for you. So how was your first encounter with Dr. Sarabhai?
As I said, that I met him in 1916, and the first encounter in that 1 hour, we talked about various things. He not only asked me about the physics-related questions, but he also asked whether I was interested in sports. I later on came to know that Dr. Sarabhai was a very good cricket player. And I used to play cricket, table tennis, badminton. So we talked about those things also, not just only about the studies or the research work which I wanted to carry out, but also about all the other things.
Yes, sir.
Thank
Even
you.
I have heard that, I had read that Dr. Sarabhai was an all-rounder and enigmatic personality, not just space, science, technology, cosmology, physics and science in all its forms. He took
Yep.
interest in that. And plus, like you mentioned, sports and also music.
Music, yes.
Yes, I have heard.
He was very much interested in music, the dance form. He was married to Mrinalini Sarabhai.
Yes, yes.
She was a very well-known Bharatanatyam exponent, and she had started her own academy also, Darbana Academy in Ahmedabad. And we used to discuss later on, once I moved to Ahmedabad, later on we used to discuss various things about the music systems also, the kind of amplifiers, the loudspeakers, the microphones that are used, certainly.
Yes, yes. Acoustics and all the
Yeah,
technical aspects.
yeah.
Yes, I'm sure. Okay, we'll go to the next question. I think Dhanvi Shah, she wants to ask you a question, sir.
Okay.
So, firstly, it's a great pleasure for me to have a word with you, sir. And thank you, Vidyadan, too, for giving this wonderful opportunity to me. So, my question to you is how was your overall experience with Dr. Vikram Sarabhai? And is there any memorable experience you would like to share with us?
Sure. The overall interaction with Dr. Sarabhai was really very good right from the very beginning. He used to work almost day and night, anytime, and particularly after we started our satellite tracking related work. Anytime in the night also, if we were to see that lights were on next to our satellite tracking trailer, he would drop in there, ask questions about, and also see what we were doing, what were our working conditions, whether there were any problems. And generally, he used to discuss about the work there. Later on in Trivandrum also, whenever he used to come to Thiruvananthapuram, throughout the day, we would be looking at what was going on a regular work-related basis. But then later on, in the evenings, we would sit down and discuss about the future-related projects and what we should be doing later on in the future-related projects, particularly connected with our own development of the rockets in the initial period, and later on about what we should be doing for our satellites and communication satellites in particular. Dr. Sarabhai was also very much interested in the development of science education. And what he had seen, which was happening, was that the students were not getting enough opportunity to carry out the experiments by themselves. They were being shown the experiments being carried out by the teachers, but the students were not getting the opportunity to do these types of experiments. And the same thing, he was also looking at it, saying that, okay, why only the students who are today in the school? The general public also wants to know various things, and they should also get an opportunity to carry out some experiments. And that's how he conceived and started the Community Science Center in Ahmedabad. And that was the beginning of this type of a idea that there will be various laboratories connected with physics, maybe connected with biology, chemistry, even mathematics. And students should be able to come there and carry out these experiments. And now this was established in 1970. And I think that really came out very nicely. He used to discuss with us also, even in those days, that one of the costly items in the school experiments or the laboratory equipments was a microscope. So he was asking us, can we not develop a microscope through which the students can actually see small organisms like amoeba in water at a cost less than 100 rupees. So yes, we had taken up the task at that time, and it was developed by Dr. K.B. Shah and some of the other people. And that particular knowledge was transferred to a company in Bangalore called as Dynam. And then the Dynam came out, and this made the microscope available to the students as well as schools at a cost of only 60 rupees, even in those days. So he was very much interested in spreading science education at every level, not just only at the higher level of PhD or that kind of a thing, but basically for every person one of the interesting things to share with you all would be in 1964, Dr. S. Chandrasekhar had come to Ahmedabad. Now, Chandrasekhar was very well known because of his earlier work on the astrophysics. And now that Chandrasekhar was going to come to Ahmedabad, first Dr. Pandya, SP Pandya, he gave us a lecture as to what Dr. Ramanathan would be talking with us. Then Dr. Ramanathan talked with us for about 4 or 5 lectures as to what Chandrasekhar would be talking with us. And we as the students, we should be learning certain things. And in those days, the auditorium or the simple hall which we had could not have accommodated more than about 55 to 60 people. So as young students, we were really worried whether we will get the chance to listen to Chandrasekhar or not. But Dr. Sarabhai gave me a very interesting responsibility. And that ensured that I was able to attend all the lectures by Chandrasekhar. He told me that it's my responsibility to sit there and record every word that Chandrasekhar speaks. And because of that, I got the seat right in the front row itself. I was able to record everything. And later on, it was transcribed and a book came out on the radiative transfer of heat. Now, Chandrasekhar told us various things about what is inside of a star, how things happen in the star, because he had done his original work. If you read through it, you will find out the original calculation for the black holes. Chandrasekhar had done as early as 1930. Later on, when he got his Nobel Prize, it was quite late, but his early work was also recognized for his Nobel Prize. And because of Dr. Sarabhai, we got opportunity to have various Nobel laureates, various people coming from different laboratories, different countries, and giving the lectures at that place.
Yes, like you mentioned, I'm sure he was such a visionary, and Dr. Sarabhai could connect from the kids to youngsters, to scientists and people from all streams. And I'm sure he had such a magnetic personality. They say that he could bring together people from all aspects, and bringing together all of you at Indian Space Research Organization, that itself, the establishment itself, I'm sure it's a great contribution. And he was a great inspiration for all of you. And I'm sure also for all the other people from foreign universities. And I heard he had connection with, because he studied at Cambridge and also with NASA, with the European Space Agency back then. Yes. Okay, so now we'll go to the next person, next student, Pravan Chinmay. Pravan from Chinmay Vidyalaya. Okay.
Hello, sir. It's a very good honor to meet you. My question is, what is like to work in the ISRO?
Well, the first work was on the rocket launching. Later on was on the communication satellites, the satellite instructional television experiment. So this was a very important experiment. We were going to use an American satellite. Just to give you some idea, when we get a signal from the satellite, the signal is fairly weak. And in order to receive the television signals way back in 1967, 68, people used to require a very large antenna dish. The kind of a dish would be maybe 30 meters diameter. That level of a dish would be required. NASA was looking at a new satellite coming up in which they were going to put a large dish on the satellite so that on the ground we could use a smaller dish. And so this was the satellite, Applications Technology Satellite ATS-F. And that particular satellite was being manufactured in USA. The ground systems we were going to make in India, and the plan was to get the television signals to 2,400 different villages in India, all across, starting from Andhra Pradesh, Karnataka, Madhya Pradesh, Rajasthan, Bihar, and Orissa. And this was the experiment to be carried out using that American satellite. Our idea at that time was that, okay, we should know about that particular satellite and also carry on the studies so that we could make our own satellite in the future. And so one of the assignment for me was at that time to study about that particular satellite, be at the Goddard Space Flight Center and carry on the work there, making certain that as a systems engineer, I should be able to make certain that what the American satellite that was being built and our ground systems which we were making in India, they should function together. And that was a very important work that was to be carried out. And so once that particular systems engineering was established in 1973 January, I came back from USA, and then it was decided that I will work in Ahmedabad for this satellite instructional television experiment, but I should be available for our own satellite, that was the INSAT satellite, which was to follow. And later on, it so happened that I had to take on the full responsibility for these 2,400 village receivers. We developed the receiver in Ahmedabad, transferred the technology to the Electronics Corporation in Hyderabad, where they made all these 2,400 television sets which were capable of receiving the satellite signals for the first time, and also 2,400 10 feet or 3 meter diameter antennas. And then we established them in the villages, and we conducted that experiment in 1975, 1976. After that experiment was over by 1977, then I moved to Bangalore because it was decided that we are going ahead with our Indian national satellite for the television, telecommunications, and All India Radio also, and meteorological Earth observations. So if we had a geosynchronous satellite, which is a stationary kind of a satellite at a distance of 36,000 kilometers away from the Earth, that satellite can also have a camera. And from there, we should be able to get the images of the Earth to study the meteorological movement of the clouds, as also development of the storms, etc. And so that's how that work was taken up by me, and I continued with that work until 1987. Then I moved to Ahmedabad as the director of the Space Application Center, where I had to look after many more things, not just only the satellite-related things, but many of the other things. And we made our own Indian remote sensing satellite there. And later on, I moved to the Vikram Sarabhai Space Center at Thiruvananthapuram. And it was 1992, we had tried to launch our Polar Satellite Launch Vehicle, PSLV, and the first D1 flight, it had a failure. 1994, when I moved to Trivandrum, one of the tasks that I had for me was the ASLV D4 and the PSLV D2. These are the two missions which we had to make successfully. And yes, we did that thing successfully. So quite a lot, different kind of works which I have carried out.
Yes. Okay, so now the next question will be from Amu Anthony.
Yeah. Hi, sir. Good evening. My name is Amu, and I just want to say it's a pleasure to be with you here today. So I'm an ardent lover of science-related subjects and the latest space science discoveries. So I just wanted to know how you see the future of space tourism and how you think it's going to impact our understanding of space.
Okay. Space tourism is a very interesting idea. Okay. In the initial period, various people thought that space tourism will be taken up by various people as part of their adventure sports or adventure-related things, because it's a risky thing. Today, what is happening is that the space tourism has come up to the stage that if you can cross 85 kilometers height, which is called as the carbon line, then you are considered that you have gone to the space. So that was one of the new things that has come up in the last 4 or 5 years. And I think space tourism is going to grow as an industry. Uh, New things will come up. Space tourism, people will get various ideas also. You know, this Jeff Bezos, from the person who started this Amazon, he has also gone through that. Richard Branson has gone through his own ideas. So various ideas will be there for the space tourism, not just only going up to the suborbital height of about 85 to 100 kilometers and coming back, but also going in the space and spending some time there. On one side, the tourism-related ideas came up, but simultaneously, the International Space Station idea also came up. And in the space station, many of the astronauts have lived there for long enough time. I think this astronaut Sunita Williams or Sunita Pandya, she spent more than 6 months in that International Space Station. Now, once the idea comes up that, okay, this is how we are going to go ahead, the next level would be to not just only go to the space for a certain amount of time, but the future could be establishing a habitat on the moon. That's the next step. Away from the Earth would be nearest is the moon. So on the moon, there could be a habitat which is located. Various new ideas are also coming up for the International Space Station. International Space Station was supposed to be closed down in 1920-21, but now I think it is going to be extended up to 1928. 2028 or 2029. And recently now India has also signed this Artemis Accord. And so therefore we could also be looking at taking it up further. There are various new ideas that are coming up about manufacturing in space also. Not just only manufacturing certain things on the ground, but for anything that is connected with metallurgy or connected with biology or so, some of the chemistry related things. Since it is in the zero gravity situation at the International Space Station,
Yes.
Things which you can carry out in the zero gravity have got different characteristics, because as you know, on the ground, whenever we heat up something, in a liquid, for example, convection comes up, and due to the convection, there is continuous movement. While in the zero gravity, there will not be any convection. And so we can grow larger size of crystals, larger size of molecules, and therefore there could be a space industry also coming up. Things which are manufactured in space brought back to the ground. One of the things that they had been able to do was to grow a extremely high purity glass and melt it there in space. But once you bring it back from that level, kind of a glass, we can make very fine glass fibers. These fiber optics or glass fiber, which is now being used for giving us internet, various communication systems, those things also will now start coming up, because that high purity type of a glass fiber means that we will require less number of repeaters. So there are various new ideas that are coming up, but the space tourism has also come up with various other ideas also. What happens if there is an accident? What kind of accident insurance will be required? What kind of international law will apply? So if somebody is looking at a career in this kind of a thing, you should be not looking at only the technology. All the other social aspects are also going to be important. The astronauts who go there currently, they don't have any direct access to, medical treatment. But if somebody is going to be there for about years together, that far away from the Earth, there could be some very specific things going on regarding what can be done for the astronauts related their health problems and their systems which are there.
Yes, sir. Absolutely. I guess the long term, staying there in the space station or colonizing moon or a habitat. That calls for many aspects, and I'm sure scientists all over the globe and space agencies are working on this. And also, like you said, the metallurgy and manufacturing, I heard also 3D printing and all that they carry out in the space station these days. Right. Okay, all these answers are very fascinating and interesting, and the students are listening, hearing this for the first time. So you have no idea how fascinated they are. Okay, there is Sai Charvik. Let us get a question from him. Sai.
Hello, sir.
Yes.
Hello.
My question for you is that what do you think about our generation in terms of overall skills and knowledge about space engineering?
I personally find it's really fascinating to meet with the young children or the young students. They have their own extremely good ideas as to what can be done, how things can be done. One of the very interesting project that I got involved after coming to Pune recently was when the engineering college students of College of Engineering in Pune, they wanted to make a satellite, a very small 1 kilogram weight satellite. And when they were designing it, they were going through various phases of it, testing of it. Since I was in Pune, I started helping them, and they had extremely good ideas as to how such a small satellite can be passively controlled. And so we used to sit down and discuss various things. All these people, they also came up with extremely good management system by themselves, because college students, they will be there for about maybe 2 to 3 years. The people who are in the final year, they will be moving away from that. And how to make certain that the documentation has been done properly, so that they can hand it over to the next level of the person who comes in. So every year there was a new project manager. The faculty members were there to guide them, but the students managed it themselves. I'm quite certain that the younger generation has got extremely good ideas, and I'm certain that they have the skills. They have the access today to the internet, the kind of things that we never had even dreamt about. We were always dependent only on the library, but other than that, other information was not that easily available. Today, with the internet, the students have got access to all this information, the technology, the knowledge, and the contacts through internet. So I'm quite certain that there is a bright future for all the students who will come up there. Some of the young students, I know one of the very young students who is in the school, but he wanted to develop a rocket by himself. They have been able to develop the propellant, and he has come up with excellent ideas, certainly.
Yes, age is no bar. I guess students are starting at a very tender age these days, and they have the ideas, they have the passion for that, and they have the resource persons, and experts, also inspiration from people like you. So I'm sure this will go a long way in India's space projects, also from the private parties and the startups. Today they are all coming up in a big way. Yes, so the next question is from Pranav Jyoti.
Yeah, a very good evening, sir. This is Pranav.
Evening.
It's an honor meeting you, first of all, and thank you, Vidyadhan, for this opportunity. And my question for you is, could you share a challenging moment you've experienced while working on a mission, and how you and your team were able to overcome the challenge?
Okay, I think one of the very challenging time was when we had launched the INSAT 1A, and it had certain problems. INSAT 1B was launched using the space shuttle at that time. It went up on the Challenger, and when we were working on getting the satellite out from the space station, this space transportation system, it went through its own motion, and then also indicated that there was a problem. So that problem had to be sorted out, and so our entire team from the Ford Aerospace, which had made some of those things, and our team were to come up with a proper contingency-related plan. And it took us something like maybe 4 days for us to finally get to the point of solving the problem and getting the solar array out properly. But it was really a very, very challenging time period at that particular time. We had challenges later on also when we were looking at the PSLV launch vehicle also. The PSLV D1 had a failure. So we had to first of all sit down, understand exactly why such a failure occurred and what corrective actions are really required to be taken. But after taking the corrective action also, to get the first vehicle out after the first failure was really a very big challenge. And we were able to do it successfully. And PSLV D2 was launched in October of 1994. And that was very, very challenging work. Today we're looking at it that we're after that, I think hardly 1 or 2 failures must have occurred. Today we're at this, I think last one was C56 continuing was launched. PSLV has turned out to be an excellent vehicle, not just only for our own satellites, but also we have been able to launch quite a large number of foreign satellites also using the PSLV. I think the largest number we were deployed was 104 satellites when we launched. Yes, that was a very good work that has been now done. Sure.
Okay. One question a student is asking, what was Dr. Sarabhai's dream and vision? And some of his dreams have been accomplished and achieved by ISRO scientists and engineers. And in the future also, I'm sure they will be accomplished. So what are those dreams? What were his dreams like?
Well, I think one of the first thing that we used to discuss at that time was being able to get the television systems working throughout the country so that every village people should be able to get it. At that time, our idea was that we would use the community receiving systems. But today, instead of community, I think we are getting to the direct to home kind of television system. His idea of making full use of the capability of the television system for education has not really fully materialized. We are using the television systems, the computers together as computers and communications put together as with their convergence. During the pandemic, it was very specifically seen how we can actually use all these systems for our education-related things. In 1969, Dr. Sarabhai had come up very specifically with ideas that, okay, we should be looking at remote sensing as a technology. And again, I was very fortunate that when the first team got selected for that, Professor Pisharoti from Ahmedabad Physical Research Laboratory, he had joined there. Dr. Dakshinamurthy from Indian Agricultural Research Institute, Dr. Krishnamurthy from Atomic Minerals Division, and myself. So we were asked to go through the study of the remote sensing technology, what NASA was doing, and NASA had fully supported us in that effort. And we understood it. We came back, talked about it, various things, what we should be doing. And that's how this concept of our own Indian remote sensing satellites was initially brought up by Dr. Sarabhai. At that time, even the first remote sensing satellite, ERTS, the Earth Resources Technology Satellite, was not launched by NASA. They were working on it in order to prove that, yes, such a thing is definitely possible. One of the very interesting problems which was taken up by Professor Pisharoti and Dr. Sarabhai at that time was that in Kerala particularly, there are all these coconut trees everywhere. Now the coconut trees, they go through a problem that's called as a disease, which happens at the top of the tree. And it's called as coconut wilt. And this particular coconut wilt, from the ground we cannot see because it is happening to the crown of the tree. So the idea was that on a helicopter, cameras were taken up, and the cameras were having the specialized film in those days, which would respond to the reflected infrared rays from the sun, the light that is reflected by the tree. When we see it in that light, we can then find out which of that particular tree has been affected by this disease. Once those were identified, these trees were given very large size penicillin and some of the other type of injections to cure them also. And that was really the success kind of thing that happened, which led to our actual establishment of the Indian remote sensing program.
Yes.
There were certain very specific ideas that Dr. Sarabhai had about how we are going to use the space technology. And one of the very important things was that he was quite clear that we should be able to develop our own launch vehicles. So even before our small rockets were working, we used to discuss as to what we are going to do, as to how we can make the larger vehicles. Even in 1969 itself, he had put the task ahead of us, saying that we should be able to launch our own communication satellite. And for that, when we developed the geosynchronous launch vehicle, GSLV, it really proved that we can do it. One of the things which was not thought in those days was to use a small launch vehicle like PSLV to go to the moon or to go to the Mars. That has now become possible.
Yes, precisely, sir. And coming to this point now, Chandrayaan-3, many youngsters are all keen to know what will be the outcome, and I'm sure we are all waiting for 23rd August for the landing. And especially now everyone will appreciate why the name Vikram was given to this lander, named after Dr. Vikram Sarabhai. And we also heard that Vikas engine also, it's abbreviation of Vikram A. Sarabhai, so Vikas engine. So his legacy continues. And we would like to know about Chandrayaan-3, that is Vikram lander, and Pragyan rover, how the India's tricolor will reach there.
Okay. First, let me just start with this. When the idea that, okay, Chandrayaan itself, we are going to the moon, that idea came up even as early as maybe 2003, 2004 or so. At that time, again, the question was, when something has gone all the way up to that distance, how are we going to be able to receive the signals from that large distance? The distance to the moon is 384,000 kilometers. So we needed a new station to be established for this, our Indian, ISRO's tracking network, ISTRAC. Some people were saying at that time that, okay, we should import such a station. And at that time, Madhavan Nair, who was there, he was trying to get ideas to whether we should be able to do it ourselves or not. So once the idea started getting discussed, then they had contacted me, and I agreed I will go back for that particular work. And it was decided that we should be looking at our own capability of making such a large station. And then we went through the design reviews. I visited Hyderabad, Bangalore. We discussed various kinds of things. Finally, we were able to make certain that such a station can be actually built by us. That's how I got involved in the Chandrayaan-related project in the beginning. I had gone for the Chandrayaan-1 launch also. And later on came this Chandrayaan-2. Now, Chandrayaan-2, in the initial period, our idea was that we can take a vehicle all the way up to there, but the lander and the rover would be a Russian technology. It never materialized. By that time, the Russian lander also had a failure problem on the ground testing. So it was decided that we are going to make it ourselves. Now, this lander was made at the Vikram Sarabhai Space Center. And it's unfortunate that in the last final moments, instead of landing there safely, it crashed. But the portion which remained in space, there is the Chandrayaan-2, the orbiter, that has provided us with large amount of data, and it is still being still providing us very high resolution images of the moon. So Chandrayaan-3, when the discussions came up, it was decided that this time we don't need an orbiter. We need to go only up to the moon, but make successful landing there and get the data regarding where we have to actually land from the Chandrayaan orbiter, Chandrayaan-2 orbiter. Now, Chandrayaan-3 lander has been very much more strengthened compared to what it was there for the Chandrayaan-2. The lander has got many more sensors to measure the horizontal velocity, to measure the vertical velocity. We have got additional cameras, we have got laser altimeters, we have got radar altimeters. So with all these new things that came up, the question was, are we doing everything properly or not? And so in the month of May this year, a meeting was held in Bangalore, where we were again invited. We went through the entire process as to what exactly has been done, what went wrong, how it has been corrected. And once we were satisfied that such thing is there, has been done, then we were fully satisfied. Now, many people ask me the question as to why these dates are selected. So let me just very quickly say a very simple thing. We know that August 15th, 16th is the time period in which there is going to be no moon, or it's Amavasya. And August 30th is the full moon, or the Rakhi Purnima. Now, when we go somewhere, we try to make certain that after we land there, or wherever we reach there, there is daylight available to us. So now, between these two dates, between the no moon to the full moon, the light is constantly increasing on the moon. The place where we want to land should be fully lit. And after we land there, then we should have minimum 14 days of sunlight. And that's how these dates have been simply selected on the basis of the phases of the moon. So we are getting there. And the idea was to get into the Earth's orbit, slowly increase the orbit, and finally get into the orbit of the moon. Once we are in the orbit of the moon, in the initial period, it was the orbit such that it was close to the moon on one side, but quite far away from the moon on the other side, about 10,000 kilometers or so. And then now maneuvers are carried out on the lander and the propulsion module put together to reduce this orbit and finally get into a circular orbit of 100 kilometers by 100 kilometers. There is 100 kilometers height away from the moon. And then try to reduce the velocity such that it will deorbit, will get out of the orbit of the moon, and then it will crash onto the moon. So once it starts moving towards the moon, now the vertical velocity has to be reduced by using our rocket thrusters. Once that thing happens, then it will get close to it. We'll constantly monitor the height, constantly monitor the velocities, and then decide how slow we should be able to go. So finally, we had to get down to the place for landing. The height should be such that just the last few seconds, only 2-3 seconds, would be the most critical kind of time period, such that we should not have any velocity left more than 2 meters per second. Less is still better, but that's about it. What there. The important thing would be to get to that particular point, and at that time, the lander should be vertical, because it has to land there on those 4 legs. And when it is landing, there should not be any large rocks. So very high resolution images have been obtained by the OHRC, orbiter of the Chandrayaan-2. But in addition to that, the cameras which will be there on the lander, they will be taking the real-time images. And once those images are compared, we made it certain that, okay, there are no large rocks or boulders and the lander is vertical, it should be able to land. One problem which is still being thought about all the time, and that is it was seen on the Apollo 11 also. As you're approaching the surface of the moon, what is happening is that the rocket jet flame is hitting the surface, and due to that, dust is thrown up in the atmosphere. But there is no atmosphere, but dust is thrown up. This dust can then get into our cameras, and maybe we'll not be able to see it properly where it is supposed to land. So the dust and the rocks on the moon are still a problem. And I'm quite certain that with the kind of work that has gone on so far, we should be able to land the lander very clearly. Once it lands there, within a few hours or so of stabilizing everything, then one of the hatches will be opened and the rover will move out.
Okay, so there is one next question from Kaushik. Kaushik, is he here?
Yes, ma'am.
Yeah.
Hello, sir. It's a pleasure to meet you.
Thank you.
So I myself am very interested in space and I want to work in the field of space.
Mm-hmm.
So as a student, how should I prepare myself to be an aspirant to work with space?
Well, you have to start thinking as to what area in space you are interested. Are you interested in space as a physics, astronomy related things, or making a vehicle? You could study chemistry and make the propellants which are required for our vehicles. Any subject that you choose is today going to be connected with the moon also. So don't think that only you have to study physics or engineering. It could be electronics also. It could be computer science. It could be making a camera. So you have to think as to what exactly you want to do. Study that subject really in detail. Continuously prepare for yourself, study various aspects of it. And one thing which is important from the space point of view is that you must have very good knowledge of physics and mathematics. These two subjects are really very, very important from the study point of view, but you should be able to also work with others. A single person cannot do everything. You have to be a good team member to be able to work anything connected with space.
Yes, absolutely, sir. You're right. Yes, very interesting questions. And I think Niranjan Vinod also wants to ask the next question.
Yes.
Niranjan?
Yeah.
Niranjana. Okay. Yeah.
Sir, I'm Niranjana Vinod P. of 8th of Chinmaya Vidyalaya Vidyanagar Kasaragod. And I'm a very avid follower of like space related news. And I would like to ask, what is the Gaganyaan mission going to be like? What does it mean for the future of India's space related ambitions? And also what it's going to be like. So, sir, please.
Sure. I think everybody was really fascinated from the first flight of Yuri Gagarin or Valentina Tereshkova. Then came this Alan Shepard's flight or John Glenn's flight. But those were very close to the Earth. And then came the Apollo mission, which went all the way up to the moon. So people are very much interested in becoming astronauts. And it is not that only the Europeans or the Americans or Russians can do it. We should be also able to do it. And this was the idea with which in 1982-83, it was decided by our Air Force and the defense people also that there should be a flight in which Indian Air Force pilots could also go. And that's how the first two people who got selected was Rakesh Sharma and Rajiv Malhotra.
Ravish Malhotra, yes.
Rakesh?
Ravish Malhotra.
Ravish Malhotra, okay. And it was Rakesh Sharma who went into that particular flight, and he came back. That was just about the time in 1983-84 In ISRO also, we were looking at various capabilities. One of the idea was that in those days, NASA was offering that for when we launch our own satellite using the space shuttle or the orbiter, the payload specialist who is going to do this some mission critical events can be from that country which is whose satellite is going up. And so we started working on that thing, and we decided that we should have a payload scientist mission. This mission was approved. I was named as the mission director for that one. We selected two people, P. Radhakrishnan from Thiruvananthapuram and I forget the second name. Anyway, these two people, they were, but yeah, they were selected, and we were working on it. But then 1986, there was an accident, this Challenger accident, in which 7 people died. So the space shuttle program, they decided not to carry any of the foreign people getting into this kind of a situation. So later on, when our vehicles were now performing very well, a concept came up as to can we really have a mission in which Indian astronauts can be sent out from India itself using our own launch vehicle. And so this today what we call as the GSLV Mark III or LVM, that was large enough to carry the Indian astronauts, because the astronauts have to go to the space, but they have to also come back, which means that we must have the full capability of making all these systems work and safely bring the astronauts back. So this Gaganyaan mission, which has now been approved and which is going on, is to develop a space capsule which will go up with this our vehicle, carrying 2 astronauts or 3. I think it could be 3. Presently, at least, they were looking at 2 or 3. And the mission would be to actually prove that, yes, we can do this, but later on, our own people could also have our own space station. USA had their Skylab mission. Then later on came the Russian Mir station also. China had their own station. So I think there's a possibility that yes, we could be looking at that kind of a situation in the future. So it's a very, very ambitious program, but making certain that we are able to do such a large project is itself a challenge.
Yes, sir. I guess the questions will keep coming from YouTube now. The students and youngsters are asking. And one of the questions is also, Dr. Sarabhai, sir, has been instrumental in setting up, establishing ISRO, ISRO, PRL, and IIM. Very few know that Indian Institute of Management, and also for textile, when it comes to textile, it is ATIRA, ATIRA, and CEPT for the environmental aspects. So there's a huge, rich legacy that he has left behind. So what is your take on that, sir?
Well, Dr. Sarabhai was a very well-known institution builder. He established his own initial laboratory for his own work after he came back from Europe. In England, he had gone there. And from when he came back, he went to the Indian Institute of Science in Bangalore, and he was working there with Sir C.V. Raman, and Homi Bhabha was also there at that time. And then he had decided that he is going to set up his own laboratory in Ahmedabad. But before he could actually establish that laboratory, the idea came up that our textile industry also was really suffering because we did not have enough research capability to improve the textiles, to improve the processes, and therefore the Ahmedabad Textile Industries Research Association as a system was born, and he established ATIRA first, and then came the Physical Research Laboratory. he was instrumental in helping in the building up of the National Institute of Design, the Indian Institute of Management, as I said, the Community Science Center, CEP. He was interested in all the subjects, and particularly how development of the Indian talent can take place through education, through opportunities to make these things happen. So he was very, very optimistic, and he used to go from one work to another work. He simultaneously was also looking after the Sarabhai industries connected with the manufacture of the medicines in Vadodara, as well as Sarabhai engineering, that was for the mechanical engineering also. So he was a multifaceted person. As I said earlier, that he was interested in music, dance, performing arts.
Yes. So I'm sure Dr. Sarabhai, he not only inspired your generation, my generation, but even these youngsters now, they're so keen to know about him, about his contribution, and just one session is not enough to know that. And we would like to have some more series of, such webinars. And the best part of it is that the students and the youngsters, teachers also from Vidyadan Foundation, they are so keen to know about Dr. Sarabhai, and so also about Dr. Bhabha.
Sure. I think you organize such a session, I'll be always available.
Yes, sir. And any other students wish to ask any questions? So one question now, just yesterday I heard, by the way, now this is the Russian spacecraft Luna.
Yeah, Luna 25.
Yes, 25 has been launched from Russia. And on 10th August, yes, it was launched, and it might take just 6 to 7 days. That is, it means 18th or 19th or something.
Let me tell you one thing about that. Luna 25 is a straightforward lander type of a craft that they have made. The last major effort was in 1976, and after that they are now coming up for the first time.
Yes.
Luna 25 is going to be a lander only. There is no rover in that one. That's what I understand.
Yes.
And it's on a direct transfer mission. So within about 5 days after it is launched, they should be able to get into the lunar orbit. Now, their rockets are much larger. It's a large vehicle also.
Yes.
So it is a similar kind of a trajectory or the mission that they had used earlier. Initially, they had planned to land on the 23rd of August, as I had explained as to how those dates are selected.
Yes.
Because once they land there, they also require sunlight and to do all the experiments, whatever they want to do. But this is a much larger lander, and their mission objective is to be there on the surface of the moon for the first time for more than a year or so. What happens is that in the direct sunlight, the systems get heated up, but when it is extremely cold, when the sunlight is not there. Now, when the sunlight is not there and it gets cold, the next time when the sunlight comes, by that time, many of the electrical subsystems, the batteries particularly, they would also die down. But they want to make certain that they have a mission which will last there on the moon for a year or so. It has got a robotic arm on it, and that robotic arm will do certain amount of drilling exercises on the surface of the moon. Their experiments are different, but yes, they have now launched, and because of their large launch vehicle, and since they have done this kind of a mission earlier, they could be landing before our lander lands there.
Yes.
Now they're looking at, as of today morning, what I saw in the news was they're looking at 21st as the landing date.
Yes. Okay. Yes, like you said, they are such powerful rockets. The Russian and also America's Saturn V, maybe 1,000 times more powerful than our GSLV.
Not 1,000 times, but at least 6 times more.
6 times. Okay, yes. And so therefore it takes less time, and people don't understand globally the trajectory, the orbital mechanics. But what India has mastered, ISRO has mastered, is when it came to Chandrayaan 2 also, and Mangalyaan, and this 40 days and a long period. So we'll come to the thing that budget. India does, or ISRO does it at a shoestring budget.
It's not a shoestring budget. Let me be very frank with you. This is a overall cost is also fairly large amount of cost, large amount of effort. We have got talented people. Our industries are supporting us, and once these missions were designed, Chandrayaan, idea was to use the smaller launch vehicle like PSLV to launch Chandrayaan 1 and at least have the moon impact probe on it, MIP. And then came the Chandrayaan 2. And because of the lander and rover, it was decided that we are going to use our larger launch vehicle, that is LVM or the GSLV Mark III. The mission, once it has been designed, it's not good to change and tamper with it, because this type of a mission, once we have done it properly and landed on the moon properly, similar kind of a mission can also be performed to go to the Mars also. It is not, when it comes to the Mars, there is no way that we can go on a direct trajectory. As far as the moon is concerned, using the large launch vehicle like Saturn or this Soyuz, they have the ability to go to the direct transfer. But again, you should remember that our PSLV or the GSLV, the height of our vehicle is only 44 meters, while the Saturn itself was 112 meters long. USA has now been coming up with a very large rocket, particularly the Artemis program. It's a question as to how you want to actually see the mission. Even if it takes more than, say, 8 or 9 months to reach to the Mars, quite okay if we can still use a smaller launch vehicle, whatever capabilities we have. We must really make certain that whatever capabilities we have, we must fully make use of it and then move to the next level.
Yes, if there are any other questions, we'll take them, or else we'll come to the end of this program. Yes, I would like to also add that Dr. Sarabhai's dream was, and his vision was, not only do space programs, but space technology, satellites, all the satellites and space related technology he thought we should bring, and also spin-off, like what you mentioned, bring that technology to solve day-to-day life problems.
Sure.
So agriculture, and make farmers' life simple, and also telemedicine, teleeducation, and the fishermen, help all the common man of India, and
Sure.
also defense related applications. So I'm sure we can say his dreams are, they were far-fetched at that time, they might have seemed, but he had a vision, and he, with a team like you all, the dreams have been accomplished.
Yeah.
And from a modest beginning, Indian Space Research Organization has come a long way, and our best wishes to Chandrayaan 3 and to all the further missions, Gaganyaan and other missions that will come in the following years, Mangalyaan, and then Aditya mission to Sun and Shukra. So India has huge set of, ISRO has a set of many missions in the pipeline. And we collected a few of the pictures, very rare photographs. And this is a logo that, the legacy that he has left, and he inspired youngsters, scientists, engineers. So I'm sure today's youngsters will also know this. And yes, I would like to quote, let's go to the previous slide. Dr. Sarabhai's quote. Yes, he said, we do not have the fantasy of competing with the economically advanced nations when it comes to spacefaring nations. But we are convinced that if we were to play a meaningful role nationally, we must be second to none in the applications of advanced technologies to the real problems of man and society. So the vision was very clear, crystal clear. And at that time, we were the third world, and we were a bit far in the race. But do you think, sir, that today we have come to a stage where we are among the top 4, top 3 nations?
Certainly, we are amongst that kind of thing. Only when we have reached to this level, today, there are many countries, many people who are coming to us to get their satellites launched. Yes. This kind of a confidence that they have is because of our technology, the reliability that has been built up, and that's very important.
Yes. So the students are very keen to know, and we are all waiting for the Vikram lander to touch down and touch base on the south pole of moon, and history will be created, I'm sure. So we are looking forward to many, many successful missions from the Indian Space Research Organization. And like you said, sir, 615 crore rupees is not a small amount, and it's not huge as compared to the other nations. But yes, we are doing such great work, and I'm sure we are also inspiring the youngsters to come up also with startups. So that one last question, what do you think about the private space startups ecosystem in India?
I think it will be very good when they start getting into that situation that they are in a position to actually make large launch vehicles. I think one of the first thing that is going to happen is that I think our PSLVs will be made in the local industry, and ISRO will then continue to do the development of advanced vehicles, because our next level vehicle is going to be a fully reusable technology in which the vehicle can get into the orbit and come back and land like a plane. So this new technology will be very, very important to be developed. And if the private industries take up the current related work, then ISRO can concentrate on the future related missions and the future related. Even as it is today, we must remember that the total program is so large that ISRO is not doing this thing alone. Okay, more than 75 to 80% of the ISRO's work gets done in the industry. It is our industry which has been constantly contributing to the making of the engines, to making of the rocket shells. Currently, ISRO is involved in basically the making of the solid propellant, but some of the liquid-related engines are coming now from the industry. If these industries really want to take it up further, one thing which they need to really do is to establish at multiple locations the test facilities. Because finally, right now, what is happening is that everybody is dependent upon the ISRO's test facilities which have been established. I think the private industry also should be now establishing test facilities for the future related work, so that they can carry out the testing in their own locations also for their own industry.
Yes. So thank you very much for your insightful guidance, and the students are inspired by your talk, and the interaction went off very well, and they're all going to take home. The takeaway is that they are going to be inspired, and already the ignited minds, the youngsters are aspiring to be the future space scientists, engineers.
That would be nice.
Yes, we would like to see them all. Yes. So best wishes to Indian Space Research Organization for Chandrayaan 3's lunar landing, that is Vikram lander on the south pole of moon, and Godspeed. Best wishes to the youngsters, to Vidyadan Foundation, and thank you very much, sir, for being here with us, and we look forward to your further future interaction as well. Thank you.